Okay, so we're going to begin this tutorial by discussing what is the difference between uncompetitive inhibitors and non-competitive inhibitors. Okay, so this I feel like is a good question that many biochem teachers, biology teachers ask their students, as I am a biochem student myself. So what I'm going to do is just give you a really quick, brief breakdown of the differences between the two. And if you want any further information about it, you could request an additional video, but I didn't want to make this video too long and drawn out. So I'll just give you a brief, general, basic description of the two. And you might see some wording that might be foreign to you. If so, again, just request another video and I can go in depth about it. But so what we're going to do is we're going to consider first what an uncompetitive inhibitor is. So what I'm going to do is I'm just going to give you straight out the book definition, okay, and then we'll go into depth. Or actually, I think it'll be better if I just give you a T-chart. So uncompetitive versus non-competitive. Let's do that in a different color. Okay. So let's choose a different color for that. Versus non-competitive. So basically I'm just going to quick T-chart and give you some generic differences of the two. And like I said, if any information seems foreign to you, just request an additional video. So with uncompetitive inhibitor, what's going to happen here is the inhibitor, so inhibitor binds only, and I'm going to capitalize that because this is significant, only to the enzyme substrate complex. So in a lot of biochem books or biology books, you'll see the enzyme substrate complex abbreviated ESC or ES complex. So remember that the inhibitor binds only to the enzyme substrate complex. So that's one major difference between non-competitive and uncompetitive inhibition. So with non-competitive inhibition, the inhibitor and substrate can bind simultaneously. Okay, so as you can see, that's a difference in itself. So with uncompetitive inhibitor, the inhibitor binds only to the enzyme substrate complex. Okay, so that's what's occurring with uncompetitive. With non-competitive, the inhibitor and substrate can bind simultaneously. And when I give you the definitions of the two and a pictorial representation, you'll get a better idea of, the bigger picture of the differences between the two, because not only can the non-competitive inhibitor and substrate bind simultaneously, but the non-competitive inhibitor can bind to different binding sites, okay? And that's really significant when it comes to inhibition, specifically non-competitive inhibition. Okay, so what I'm about to tell you now is something that has to do with McKillis-Menten kinetics. I'm not sure if you've gone over that yet, but if not, like I say, you can request an additional video and I can break that down. So if this seems foreign to you, again, request an additional video. If not, then it will make sense. So what occurs on a McKillis-Menten plot or McKillis-Menten kinetics, your Km for uncompetitive inhibitor goes down, and your Vmax goes down also, goes down, okay? So try to remember that. Like I said, if it doesn't make any sense, just request a different video, okay? So your Km value goes down and your Vmax goes down as well when you're looking at McKillis-Menten. And for your non-competitive inhibitor, what's occurring on McKillis-Menten plots, your Km is unchanged, or doesn't change, should I say. I like the word doesn't change better, so let's just say doesn't change. All right, so that doesn't change, and your Vmax goes down. And like I said, this might seem foreign, but it all makes sense when you look at the McKillis-Menten plots. So these are the major differences between uncompetitive and non-competitive inhibition. I'll just give you a quick pictorial representation and examples of the two, and hopefully that kind of sums up the difference between the two. Alright, so what I'm going to do is erase this and give you the generic book definition of uncompetitive inhibitor, give you a pictorial representation, and then move on to non-competitive inhibition. Okay, so hopefully you can understand it, and I've answered your question thoroughly. That's what the goal is, okay? To answer your question thoroughly. So what I'm going to do is I'll just go ahead and give you the definition of uncompetitive inhibitor. So let's clean this up a little bit better. So sorry about that. Get it a little bit better. Alright, now we can move on. Okay, so by definition, uncompetitive inhibition. Uncompetitive inhibition. By definition, that is a substrate dependent inhibition in that the inhibitor binds only to the ES complex. All right, so that's what the major point is. So it binds only to the ES complex, and like I said, I'll give you a quick pictorial representation of that. So here is my enzyme, okay, and here is my substrate. And the substrate binds to the active site. Okay, remember that. Substrates bind to the active site to activate the enzyme. And you have many different types of enzymes. You have kinases, isomerases, hydrolases. The list goes on, and they perform different jobs. So in blue, I'm drawing the active site. Okay. So what we have here, the yellow and the red and the blue, that's your ES complex. Okay, that's your whole enzyme substrate complex. So remember that. All right, your substrate in yellow is bound to the active site in blue, and the active site in blue is a part of the enzyme. So that's your whole ES complex. So your uncompetitive inhibitor, I'm just going to draw a square as the uncompetitive inhibitor. Okay, so your uncompetitive inhibitor binds to the ES complex, which is the whole blue, red, and yellow. Okay, that's where your uncompetitive inhibitor binds to. Okay, so that's just your quick, generic, basic, to the point what is occurring with uncompetitive inhibition. And your example is Roundup. Okay, your example for uncompetitive inhibition is Roundup. And that's the chemical that kills shrubs and weeds, so on and so forth. And now we're going to move on to non-competitive inhibition. Okay, if I'm going too fast, you can always pause, rewind the video, or request additional information. Okay, so just keep that in mind. Keep that in mind. So now I'm going to do non-competitive inhibition. Non-competitive, so non-competitive inhibition, or inhibitors. I'll just write inhibitor. Non-competitive inhibitors. So by definition, I'll give you the mechanism of action of non-competitive inhibitors, what they do, and I'll kind of give you a generic definition. So non-competitive inhibitors, they can bind simultaneously, as we said before, simultaneously to an enzyme at different binding sites. So the enzyme, this non-competitive inhibitor, can bind simultaneously to an enzyme molecule at different binding sites. And what I mean by simultaneously is it can bind simultaneously with the substrate. Okay, and so what the non-competitive inhibitor does is it acts by decreasing the overall number of active enzyme. Okay, and that's kind of, when I draw the enzyme out, it kind of makes sense. Okay, it kind of makes sense. So let me draw the enzyme. Okay, so here's my generic enzyme again. So what's occurring is I'll draw my generic, here's my generic non-competitive inhibitor. Okay, so what's occurring is my non-competitive inhibitor is bound to the enzyme, okay, at a different, just at a random binding site here. I'll say random because it could bind to different. So, and here's in green, I'm drawing the substrate. Okay, substrate in green, and in yellow is just the active site of the enzyme. So what's occurring is my enzyme in red is bound, or the substrate in green is bound to the enzyme. Okay, we got that. So the non-competitive inhibitor in brown is bound simultaneously with the substrate. Now what will happen at that point? Is the active site, or the binding site where the substrate is bound to, will change shape. Okay, will change its shape. So now it's going to look something rather like that. Okay, now if you look at that, the substrate is not exactly built to fit that change shape of the active site or binding site. It's kind of like analogous to lock and key. Okay, so when you have a key that is made for a specific door, it's going to work for that specific door. But when you change the shape of that insert that the key goes into, the key won't work anymore. And so that's analogous to what I've drawn here. So we have changed the shape of the enzyme active site, and now that enzyme can't work. And that's how non-competitive inhibition works. The inhibitor in brown binds to a binding site and changes the shape of the active site while the substrate is bound. So as I said before, a non-competitive inhibitor acts by decreasing the overall number of active, so the keyword here is active, enzyme molecules. Okay, so that's just a quick and basic overview of uncompetitive inhibitor and non-competitive inhibitor, also the differences between the two. Hopefully you enjoyed the video, learned a little bit. Always looking forward to feedback on how we did with making the video, but hopefully you got a better understanding of the differences between the two.